now welcome our next speaker, Matthias Mehlhose. Matthias is a research associate on the Wireless Communications and Networks Department at Fraunhofer HHI, and he'll give a talk on open source 6G testbed for FR2 side link as well as joint communication and sensing. Thank you, Matthias. So the floor is yours.
Can everybody hear me? Yeah. Okay. Hi. Yeah, my name is Matthias. I'm coming from the Fraunhofer Institute HHI in Berlin, and I represent today our department and can say something about our activities in OAI, side link, and joint communication and sensing. Oh, wrong way. Yeah. Yeah. First, I want to say something about what is sidelink and JCAS, and yeah, of course, the next generation networks will improve the key metrics like the data rates and latency and reliability, and they also allow us to create some autonomous systems and smart cities and also industrial automation. And so we also increasing then the capacity, the mobility, and the positioning, also ability of the network, and this gives us some achievements to build all these new things. And we are working on an open source 6G testbed to be ready to develop and also explore FR2 side links and joint communication and sensing, because FR2 gives us the opportunity to have more bandwidth and make the better sensing. And the collaboration is also important. So if we have a test bed which is equal, so we can just put it in the lab, and the researchers and also the developers can work together on it and cooperate and bring things forward. And so we are working on side link applications like V2X, and they offer a very low latency communication. And so what you can see here is we also have already the robots and the drones equipped with OAI equipment. So it's a B210 and Intel NUC. And we are using these things to explore what can be side link and joint communication and sensing do for us. Some word what in our case can be side link do for us. So in the first example, we have here some radar sensors on the street side, and they are connected via side link to a car. So they get the information, the car gets the information via the side link, and can make a better, have a better idea how the environment looks like. But we can also use side link as a sensing. So we're using the communication signal as a, let's say, radar signal, and can also gather information from that, so that in the end we not needing separate sensors on the street side or on the road side, so we can just use, this is the idea, use a communication system also as a sensing system. And I talked about this platform. So we just taking all the components we need for this and put it into a 19-inch rack. So it's a B210, some power supply and amplifiers, and also an Intel NUC to have everything ready to use. So on the Intel NUC is OpenAirInterface code, so you can compile it, change it, and run it on that. And with this, we can also go to some equipment like our channel emulator using Quadriga to create some channels and improve the and test, of course, OAI against channels we measured or we created by the models to make it more robust and that it becomes better. And the integration of side link currently includes everything. It's not public but it's a cooperation between the Fraunhofer institutes, and we have, of course, the broadcast channel and also the signaling channel there, but also the control channel and the shared channel, and the feedback channel, so we can transfer data over Sightlink already, which is quite good. So we can now put sensing on it. We also have much cooperation with industry. For instance, we have some project here called Automotive Intelligence for or at Connected Shared Mobility. There was an FR2 front-end module from Infineon, and we just took the Sightlink code and run it with this antenna or with this module. What you see here is that here is everything integrated. So the SDR delivers some signal below 6 gigahertz. So here in this it's 5.8 gigahertz, and then it upconverts to 26 gigahertz or 26.5. And then you also have a microcontroller in it which can change the phases and also the amplitudes for each element of the array antenna, so that you can also steer beams. And with this equipment, we were able to also make Sightlink, or the first Sightlink on FR2 frequencies. It's still an FR1 signal, but as always, you begin with what is there, and then you can add all the features which is needed for FR2 Sightlink. And the colleagues also before told about our investigation in having an FR2 G-Node B and also UE there. So we cooperate with Orbismart, NI, and TMYTech to have this ready. And what we used here is the X410 and also the UD box from TMYTech and the B box. So it's the same procedure. We create a signal interference intermediate frequency at below 6 gigahertz, and then we upconvert it to 28 gigahertz. And we can use with the SISOLink bandwidth of 50, 100, or 200 megahertz with some commercial modem. We also heard from Quectel. I think the OAI UE is only able to achieve 50 megahertz, but it also works. And we created this together in March, I guess. It's a long time. But what I can really show is we also put effort to have MIMO. So we put a second antenna on it, and we show the first ready and stable FR2 MIMO configuration against the Quectel modem. And it works. And it's also, if you show, I show the rank indicator of the dashboard from Orbismart, and you really see that it's a rank 2 communication. And we are trying to get this also ready for 100 and 200 megahertz. But I think we are very close to show that this is possible with OAI, which is quite cool. We also have investigations to build our own SCRs or radio units. So the picture here shows some software-defined radio, 8-port software-defined radio we created in the past together with NIT in Bonn. And we want to adapt this idea to create our own radio unit for FR3 in another project. And so far we have integrated also the PTB, so the White Rabbit protocol, which is useful, and it also will have the DPD, digital predistortion and request factor reduction in it. And the target is FR3. The CPRI, the eCPRI is also working currently on our evaluation board. And at last, we show, it's not the last slide. Here we show some fancy antenna from IMSC. We are currently have in our lab, and we're looking into it, what can it do. And we will use it for, so it's FR2, and we will use it for sensing tasks. So it's a 300-degree array antenna, and we can steer the beams via SPI. So it's also able to connect like on the X410 later, and so want to use it in this area also. And yeah, we also, the video is not there, but yeah, we already talked about our activities in the in higher frequencies, let's say, the VST3 from OAI, together with some up-down converter, additional up-down converter for 160 gigahertz. So we are able to make sensing even on higher frequencies and high bandwidth. Yeah, and with this, I will close this talk. Thank you very much.
Thank you, Matthias. So I think we have time for one question.
Excellent work and talk. Thank you, Matthias. Question about the side link. You mentioned it's not available, the code, but you're planning to release it?
We have it internally, but the problem is that we cannot make everything open because it maybe hits some of our patents. So we need to find a way to share the code, maybe in the future, but currently it's not possible. So I think we already shared, maybe Robert can also say something to this. We already shared some code, but not everything, because some hitting our patents.
Got it. Okay, we can talk offline about that.
Yeah.
Thank you.
Thank you. So there's another question.
Yes, okay, so thanks for these presentations. Jerome Harry from Eurocom. Just one question related to your prototype in SideLink when you rack them up.
Yeah.
Did you I saw that you were also the band 47, so for 5.9, and that's one of the challenges also to get the power amplifiers. Did you add also power amplifiers in that prototype, and, or you did use any power amplifiers?
So the prototype consisting only on the normal user piece, so we just put it into some boxes. And the FR2 equipment, it's just a normal external setup.
Okay, but the B210 do not have power amplifiers to reach the 23 dBm powers for 5.9. That's why I was wondering.
Yeah, so the B210, it's so we put it on this drone and also on the spot, and so the thing there is some energy stuff. So we know that the B210 is only 40 megahertz and maybe not capable for SideLink and sensing, let's say. But SideLink is working on this. Yeah, so we use this the SideLink implementation with the B210 at 40 megahertz currently.
Okay, and at which power did you emit?
The power on the
air, so 23 dBm or less?
Yeah, so I think the B210 delivers 0 dBm, I think, okay. Plus the amplifier we have at, I guess, 30 dB, so it's around 25, I guess. Yeah.
Okay.
I don't measure it
so let's continue the discussion during the lunch. You have to move to the... Thank you, Matthias, for your nice talk.